Okay, so with Python numbers, there's various different types of numbers available to us in Python, but we'll mainly only be working with two specific kinds, and those are integers and floating point numbers. Integers are whole numbers, 1, 2, 3, 4, while floating point numbers are numbers with decimals, 1.2, 5.6, pi, so on and so forth. So Python has all basic mathematical operations built in, so you can pretty much just use Python as a simple calculator if you wanted to, where you can add, you can subtract, you can just multiply or divide. And the way it works in the Jupyter notebook, or even in just in any other environment where you would type in Python, you can just type in the mathematical expression that you want to evaluate, and then you just print out the result like this. So as you can see, you can do all kinds of basic arithmetic with numbers. And I want to specifically um, give attention to this one operator right here. It's called the modulo operator. Now, what the modulo operator is, it gives us the remainder of a division. So in this case, if you have a variable called x and we set it to be the value of 9, and then we do 9 mod is short for modulo 4, we get the remainder of that division. So in this case, as you can see, we get a remainder of 1. Now, this may seem like a very specific operator, but the modulo operator becomes very useful in later on when we discuss things like if conditions or even loops, because sometimes the remainder of something becomes very important to decide how long we want to repeat certain actions, or decide when we want to execute certain commands. So this specific modulo command will be coming to play pretty soon. But you can also just take a look at the cheat sheet that we provided, and you also see some examples of that as well. So yeah, you also, like we said, we can also do a slightly more advanced arithmetic, for example, powers, or even doing roots. And all those things are uh, built right into Python, where you don't need to install anything else. You can just use it as a very basic calculator, and that's just how numbers work in Python. So moving on to variables. Variables in Python are almost exactly like how variables in math are, the way you learn at school. They're basically placeholders for different values, and those values don't necessarily have to be numerical. They can be values of other data types, but because we've only really discussed numbers as data types, we'll continue just discussing numerical examples. So in this case, as you can see here, I've created a variable called a and assigned it the value 10. If I run that, you see it works just fine. And what that basically means now is that Python treats the letter a as if it is the number 10. So if I just go down here and I type the expression a plus a, Python treats that as me just saying 10 plus 10. So it gives me the result of 20. So then variables are called variables because they can vary. So yeah, they can have multiple different values at different times. So if you want to give a new value, in this case, you want to reassign it to 20, you can do that. You can just do that with no problem, and it'll give you the new result when you do the same a plus a command as you see over here. So now, when it comes to actually making names for variables, there are some certain rules that you need to follow. The first one is that names can't start with numbers. A classic example of that is if you try to create a variable called 1, that's just a digit 1. After you create that variable, when you try to access that variable or use it later on, Python has no way of knowing if you're talking about the variable 1 or the number 1. So because of that, it creates a lot of confusion, and to avoid that confusion, we just have the rule that names cannot start with numbers. There can be no spaces in the name. That means that if you have a variable name that's multi-word, uh, that's more than one word, you want to use underscores instead of spaces, because in Python, if you have a space, Python treats it as the word ending. So if you try to create a variable name with spaces, Python will just think the first word is the variable and then everything else is something else. So if you want to create a variable name with multiple words in it, you want to use underscores to link them all together and to tell Python this is all one variable name. The third rule is that you can't use any of these symbols just as a certain rule. Four isn't really a rule, it's more about good practice, and that's using all lowercase names for your variable names, no uppercase or snake case or anything like that. It's just best to use lowercase names so everything looks clean and formalized. Five is to also about best practice, avoid using letters that could be easily interpreted as others, like for example L or O or I, because they could easily be interpreted as other characters, especially in different fonts. So, and finally, you should avoid using words that have special meaning in Python, like list and str. Now, what special meaning means is that these words are specifically part of the Python dictionary, part of the language itself. So, if you create a variable called list, for example, Python has no way of knowing if you're talking about the variable list or the actual Python construct called list. So it goes back to why we have rule number one. It's to avoid that confusion. And yeah, lastly, a final tip about variable names is that you want to make variable names useful. In other words, you should not do what I did back here where you create variable names like A, B, C, D, E. You want to make variable names informative and actually representative of what values you assign them to. So in this case, if you have a very basic program to calculate someone's taxes, you have the gross income of someone, and then if you want to assign that to a variable, you want to call that variable something natural, like income or gross income, so that someone who isn't you, who may read this code later on, can actually take a look at this code and understand what it is you're doing. So in this case, they can easily tell that this number is for income, this number for tax rate, and this number is the actual taxes that are being calculated as a result of multiplying these two numbers together. So, like making sure that your variable names are informative and actually representative of the values that they're assigned to goes a long way towards making code readable. And that's readability is a huge thing you should look to, because it's also important that if you write a program that you're able to understand what's going on when you look at it 5 months later, which will be a lot harder to do if you just create variable names like A, B, C, D, E, and F. So yeah, so that's everything about variables. So now we'll actually move on to another data type, and that is strings. So strings are basically English phrases or English words in Python. If you wanted to actually type out the word hello in Python, the word hello is a string. And it's called a string because even though hello is a full word, you can basically treat it as a string of characters, HELLO, in a specific sequence, make up the word hello. So I use the word sequence there because in Python terminology, that's what a string would also be. It's a sequence. So if you wanted to create a string, you would basically just type in the word that you want to use and then surround it between quotation marks. And you can use either single quotations or double quotations. So in this case, hi, I put it around single quotations, and it doesn't just have to be a single word. You can also put an entire sentence like this. The whole thing is a string. This example uses double quotations, but you have to be worried about contractions and apostrophes, especially when you're dealing with single quotation marks, because as you can see here, Python has no way of figuring out whether something is a contraction or an apostrophe. So in this case, when it says I'm, Python thinks the apostrophe in I'm is the end of the string. So then it just sees this as complete garbage and has no idea what this is and thinks this is incorrect syntax. But that's not true because this is the end of the string. So because of this, when you're dealing with contractions or apostrophes, you should always use double quotes. So that way, when you mix the quotes like this, it doesn't create an issue. So in this case, I surrounded the string with, I created a different string but surrounded with double quotes, and the apostrophe doesn't cause any errors because Python knows that this whole thing is a string and not just, it doesn't end here. So then we can just talk about displaying strings in Python. Now in Jupyter, we actually have a very special function where if you want to display a string like this, we only need to actually just type out the string in the string format like this and then press run, and it will display it. And that's a feature that's specifically unique to Jupyter, but typically when we write Python applications or in any other Python environment, we would use something what's called a print function. Now a print function does what it sounds like. It prints something to the screen. So in this case, this is what a print statement looks like. As you can see, if I print hello world, it does that, second string. And you'll notice this here, this is what's called a -n. That's what's called a new line character. Now, in Python, when you do a \n, that basically means that you want it to be on a separate line. So as you can see here, once I execute the print statement -n prints a new line, it skips a line and then prints the rest of the line right here. And just to illustrate that point, I put a \n on the next print statement, and it skips a line again and then prints the final statement. So that's what new lines do. And as you might notice, each print statement goes over to the next line. So as you can see here, hello world, even though I didn't really put a new line character afterwards, it went to the next line anyways, and that's just how print statement works. It automatically puts a new line at the very end to start a new sentence and to start a new line for your printing. So then let's move on to some very basics about strings. So sometimes we would just want to know how many characters are in a string, how long a string is, and we can usually do this with what's called the length function. Length stands for length, where if we just do len open parentheses and then the string that we want to figure out the length of, close parentheses, and then run it, we actually get the length of the word. Now, a function is basically a specific piece of code that you can run to do a certain task. So in this case, the len function, its function is to calculate the length of any string that you want it, you give it to. So in this case, hello world has 11 characters, and you'll notice it counts the space as a character. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So even the space counts as its own character. It's not it's not separate by Python standards. So as you can see here, a string is a data type. So when you go back to talking about variables, you can assign strings to variables, as you can see here, and everything works just fine. And you can even print the actual variable, and it prints out the specific string. And now we move on to something called indexing. Now, indexing, what it comes down to is that we mentioned previously how strings are a sequence, or in the case of a word, it's a string of characters. And that means that even though a word is its own unit, it can be divided up into individual parts, and the individual parts in the case of a string is the individual letters. So you can actually access and actually distinguish between individual letters and actually extract them from the word. And the way we extract them is that each character in a string is given a certain number or an index that corresponds to its position in the string. So the first letter will have the first position, the second letter will have the second position, and so on and so forth. In Python and in a lot of other programming languages, indices start at 0. So in the case of the word hello, H has an index of 0. It is the first letter, it has an index of 0. E has an index of 1, it is the second letter. The first L has an index of 2, it is the third letter, and so on and so forth. So in the case of my string, which was hello world, if you wanted to extract the h, you would just do my string. You would just type out the variable, open square brackets, and then enter the index of whatever letter that you want to extract. In this case, I want to extract the first letter, the h, and then close parentheses, square brackets, and then press run, and it'll print out the first letter, as you can see right here. And you can do that for all the letters of my string. Next is something what's called slicing. Indexing is when you wanted to extract specific letters, specific characters, but let's say that you want to extract a big chunk of a string, multiple letters at a time. That's what slicing is. And to do slicing, you use a colon to denote a slicing operation. So in this very trivial case, if we do my string, open square brackets, colon, close brackets, it prints out the whole string, because that means that you want to slice the whole string. But that isn't very useful, because you can just type out my string and it will give the same effect. And this is very important. Slicing does not change the original string in any way. The only way that slicing a string would change it is that if you reassign the slice back to the original variable. So this operation does not affect the original in any way. So this is an example of real slicing, where I want to grab everything in my string from the start up to the 5th index. So up to the 5th index means it doesn't include the 5th index. So I want all the letters from 0, 1, 2, 3, and 4 indices. So that's in my string, which was hello world, that's 0, 1, 2, 3, 4. So as you can see here, just the word hello was extracted, and that's what a slicing looks like. And there's also like other different types of slicing, as you can see, like negative indexing or negative slicing, but you can look at that on your own time. So then we move on to certain properties of strings. Now, one of the main properties of strings is that they're immutable. In other words, they cannot be changed. Once a string is created, you cannot change the different letters within it. It's static. So just to illustrate that, if I were to try to take my string and then reassign the first letter to be A instead of H, it says right here, str object does not support item assignment. So it doesn't allow you to. So once you create a string, you cannot reassign the specific letters within it. But if you do want to create new strings from old strings, you can do what's called concatenation, where you take two strings and just combine them together. So in this case, if I have my string, which is still hello world, and then let's say that I want the string to say hello world, it's me, I can just do my string plus, and plus when you're dealing with numbers, it's just addition, but when you're dealing with strings, it's concatenation. My string plus it's me basically tells Python that I want you to combine these two strings together and create one string. So if you do that, as you can see, it creates hello world, it's me. And then you can reassign it to the original variable so that we actually store that result somewhere. And then when you print my string, as you can see, we get the new combined version. So then let's move on to some very basic string methods. Methods are basically operations that are supported by each individual data type. They're basically like different little different changes that you can make to the data type to change the structure or the way it looks that are built into the data type itself, and you don't have to use some other external function to change it in any way. So in this case, one method that's available to strings is the .upper method. And what the .upper method is that it turns every letter in the string to uppercase. So in this case, if I do my string.upper, it basically creates hello world in all caps. There's also a .lower method where it creates everything in lowercase. The split method basically creates a list of words where it separates by spaces. So it searches from string from the very start, keeps looking at the string until it reaches space, then it cuts it, and then that's one word, and then everything after it, it's another word, and it keeps going, cutting by spaces, and then just basically creating a basically taking a string and splitting it into pieces depending on spaces, and taking all those different chunks and putting it in a list of words. In this case, hello world had one space, so you get two different chunks out of that. And if you don't pass in any sort of parameters and into the split function, what parameters are, they're basically different modifiers or different options that you give to a function to change some of the internal variables within that changes the way it does its function. So in the case of the split function, uh, it has a parameter for what you would like the separator to be. The separator means the character that you want to look for to decide when to cut or to split the string into the many pieces. So the default is by space, but you can also choose some other character. So in this case, if one split it by W, I basically want it to look at the string until it finds W, cut it, and then separate the string out that way. And if you notice, it will not include the W. So it goes up to the W. It takes out the W, and then everything to the left of it becomes one word, and everything to the right of it becomes another word. So that's another way to split. Where if you have a string and you want it to split by a certain character, you can use this function, and it actually might be very useful later on. Print formatting, we don't really get into that. It's basically a fancy way for you to create new strings that isn't just by concatenation. When you actually want to use variable names, or actually create variables when you want to create new strings. And then here we have the first now try this, where we'll actually get a chance to work with some of the commands and some of the concepts that we covered about strings later on. And like we said earlier, you'll get a chance to actually work through this at the end of the lecture. So with that, let's move on to something what's called Booleans. So a Boolean in Python are values that are essentially binary. They're true or false, or 1 or 0. And on their own, they may not seem particularly useful, but they're mainly used in when you're evaluating certain conditions or when you're comparing two values to signify whether or not something is true or whether or not a certain condition hasn't been met yet. So just to illustrate, here I have a certain variable called a, and I set it to true. And you'll notice that true here is highlighted, it's blue, and that's because true is a keyword in Python. That means it has special meaning. It's a part of the dictionary of Python itself. So if I just display a, it evaluates to true. So Booleans are essentially the result of any comparisons that we make. So in this case, if I try to evaluate the expression is 1 greater than or equal greater than 2, you get back false because it's not true. 1 is not greater than 2. And there's also a third Boolean called none. So if you want to have a variable that you want to eventually set to be either a true or false value, but right now it hasn't been decided yet, you can just put it as none as a placeholder before you can reassign it to either be true or false. And like I said just before, on their own right now it doesn't seem particularly useful, but Booleans especially come in very handy when you're not just evaluating conditions, but also later on when you're filtering certain data sets to meet certain conditions or to extract certain columns. So for example, if you have a list of people and a list of ages, and you want to just extract all the different people who are over the age of 40 from your data set. In order to do that, you would basically use a comparison operation and then a Boolean. And those are all things that we will cover in due time, but especially when we start covering NumPy when we discuss filtering. But yeah, that's everything that is to do about Booleans for now. So now let's move on to another data type called lists. So previously when we mentioned strings, we talked about how strings are what's called a sequence. And a list is basically a more generalized version of a sequence. Unlike strings where it's a sequence of characters, a list can be a sequence of anything. It can be a sequence of numbers, a sequence of multiple strings, a sequence of letters and numbers. They can basically be multiple different data types at once. So the way a string looks is that you have a variable name and then you assign it and then you create a square bracket and then you list off the individual elements of a string where they're separated by commas. So in this case, I created a list of numbers and 1, 2, 3, and they're separated by commas to show that each number is its own element in this list. It's its own value. And like I mentioned, lists can hold elements of multiple data types. So if I wanted to have a string, an integer, a floating point, or a character, I can just do that. And as you can see here, it runs just fine because lists are a generalized version of a sequence. And certain functions that worked on a string will also work on a list. As you can see here, if I wanted to find the length of this list that I just created, it gives me a list of 4. And then the basic indexing and slicing that we mentioned earlier also works on lists. And you can see a lot of the more nitty-gritty details of indexing and slicing all lists here on your own time. So now let's move on to some basic list methods. So now a very common operation that you want to do with a list is that you have a pre-existing list that you've already created, but now you want to add something to it. You want to append a new value to it. So a list has an append method that's directly built in that you can use to append values. So in this case, if I have the original list over here, 1, 2, 3, and if I want to append a new string called append me, if I just do the list1 dot append, open parentheses, append me, close parentheses, run that, and then if I run list1 again, as you can see here, the append me string is now at the very end of the list, and it's now its own element in list1. The inverse of that is when I want to remove a certain element of the list, and for that, there's a method called pop. So I just do list1 or the name of the list dot pop, and then the name of the index of the element index that I want to pop off. By default, pop takes off the last index, but you can also specify which index you want to pop off. So in this case, I want to pop off the first item, and as you can see here, it returns the first item that was in the list. And now if I run to check to see what list1 looks like again, as you can see, the 1 has been removed. So now it's just 2, 3, and append me. And because pop returns the value that you've removed from the list, if you want to store it for later, you can always just assign the result of this pop function, pop method, into the popped item, into a certain variable name so that you can keep it for later. So as you see in this case, if I run .pop without any index, it automatically pops off the last item. So in this case, it was the append me. So now if I run list1 again, it just is the two numbers 2 and 3. And also here, you should notice that when it comes to indexing, there'll be an error if there is no element at that index. For example, this list only has 2 elements. So if I try to access the element at the 100th position, it'll give me an error saying that this list isn't even that long. There's no element in the list. So some additional methods you could work with are what's called sorting and reversing lists. So sorting is especially useful if you're working with numerical or even alphabetical lists. So in this case, if I have a list of all characters and I want to sort it in alphabetical order, I can basically just do it like this. Whoops, never mind that. And if I just run again, and if I run new list again, you'll notice now I basically have all of this in alphabetical order. And another method is the reverse method, where you just take the original list, and then if you run reverse on it, it just reverses the order of everything in the list. So now C that used to be the last element in the list is now the first, and the A who used to be in the first was now the last, and so on and so forth. They're very basic, very simple one-liner methods you can use that you may or may not actually use yourself in later projects, but it's good to know that they're there. So nesting lists, a great feature of especially Python lists, is that you can nest them. In other words, you can have lists within lists. So I mentioned how Python can have a Python list can support multiple different data types within it, but it can also support multiple different data structures. So in this case, you can have a list as an element within another list. So in this case, if I have 3 lists and I create a new list that is just a list of these 3 lists, we're getting into tongue twister territory over here, but if I do that, as you can see, it works out just fine. And you can tell right here that we basically have a matrix now. It's basically you can treat it as 3 rows, 3 columns, a 3 by 3 matrix, because that's basically what a matrix is. It's a list of lists. And when you actually start working with data sets, this is the type of data you'll be looking at. It's a matrix. It will be a set of rows and columns where they'll be in a tabular format, and that'll be basically what data sets are. They're matrices. They're lists of lists. So once again, we can also do indexing and slicing to work with those. List comprehensions, we won't go into them, but they're basically a very, very efficient, fast way to create a list. But you can cover this in your own time, and it's okay if you don't understand this, but just for your own reference, there's an example of what a comprehension is here. And then we have the next, now try this, but you can go that in your own time. And now we move on to tuples. Tuples are a lot like lists, except they're immutable. They cannot be changed. So as you see here, the main difference between how a tuple looks like versus a list is that tuples are created using parentheses as opposed to square brackets. And then some of the same methods that can be applied to lists also can be applied to tuples, like the length. You can also mix object types, index, slice, and so on and so forth. And tuples have two particular methods that are unique to them, and we'll talk about them right now. The first is the index method, where if you have a tuple like this, 1, in this case, it has a string called 1 and a number called 2. In this particular scenario, the tuple is very small, and and you can easily tell which position it is in. But let's say that you had a very, very big tuple, and you knew that a certain element was in there, but it's too big, and you can't really determine what the position of that element is, or what index. So with the dot index method, you can just take the tuple, dot index, and then the name of whatever element you want to put in. In this case, I want to search for the string 1. And then it will output the first index of whatever that element is. So in this case, 1 it was in the first position of our tuple, so returns 0. And then the next one is the count, where it simply counts the number of times a certain value appears. So using the same example, the string 1 appears 1 time in our example tuple. So it returns a 1. And just to prove it to you that tuples are immutable, if I try to change the first value of the tuple to change, you can see here that it does not support item assignment. And you also can't append to it, or use list methods to append to it. So you might be wondering why even bother using tuples, and it's true that tuples aren't really used as much as lists are, but they are very, very useful when you want to make sure when you have a certain set of data that you know will be static and will not change, and you wanted to keep it in a data structure where no side effect or unintended consequence of your code later on will accidentally change that data set. So let's say, as an example, you have a list of all US states. There's 50 of them. They're not going to change whatsoever. So let's just say that in your program, you're utilizing that list of states a lot, and you're passing it around between different sections of code. You would ideally want to keep information like that in a tuple in order to avoid accidentally changing that list of data in some way, or accidentally removing something, accidentally inserting something, and so on and so forth. So that's a situation where you would want to use tuple, where the set of data you have is static. Uh, that's the exact amount of data that you will ever need. You won't have more, you won't have less. So you would like it to not be changed uh, in your code later on. So you also have some couple of, now try this exercise related to tuples. Next, we'll move on to dictionaries. Thus far, we've mainly been talking about sequences in data structures, stuff like strings and lists and tuples, where data is presented in a certain order and they come one after another. But with dictionaries, we have what are called mappings, where the data is in a format called key value pairs. Now, to find a good example of key value pairs, the perfect example would be a real dictionary, an English dictionary that you're probably already familiar with. In an English dictionary, if let's say that you want to find the definition of a word, you go to the page where that word is present, and then you find the word on the page, and then you look to the definition. And in that case, the word is the key, and the definition is the value. So it's a mapping. In actual English dictionary, each word is mapped to a singular definition. So the same concept applies to Python dictionaries, where data is stored in key value pairs, where there's a key, there are a set of keys and set of values that are mapped to those pairs. But the main difference between Python dictionaries and a traditional English dictionary is that in Python dictionaries, there are no ordered keys. You cannot sort them, or there's no hierarchy to which keys came first, which keys came last, stuff like that. But whereas in an English dictionary, there's an order. It's an alphabetical order. Like all of the A words come before the B words, come before the C words, and so on and so forth. But in Python dictionaries, there's no such order like that. It's order free. So to show you what a Python dictionary looks like, it's simple. They start with a curly brace like this, and then they have the name of the key, and then the colon, and then the value, and that's one key value pair, and then comma, and then the rest of key value pairs like this. So that's how you build a dictionary. And if you can index dictionaries based on the keys. So for example, if I wanted to display the value associated with key 2, I can just do my dict key 2 like this, and then it will output value 2. So dictionaries, similar to lists and tuples, can hold multiple different data types. So for example, they can as values, they hold numbers, lists, and even lists of numbers and lists of strings, for example. And we can do the same thing where we can index them, and we can also do multiple or nested indexing, where in the case of key 3, we have a list. So if you want to output item 0, if you want to extract item 0 in this list, in this dictionary, we would just do my dict key 3 so that we access this list of values, and then 0, because item 0 is in the 0th index of this list, that is the value of key 3. And as you can see, it outputs item 0. And to go even further, you can even call methods on whatever value you output. So in this case, item 0 was a string, so you can just do .upper to show you that you can convert item 0 into uppercase. And then you can do various other different things with indexing and splicing. So then dictionaries, just like how lists were, can be nested. In other words, you can have a dictionary inside a dictionary. So in this case, the value associated with key 1 is another dictionary. And while this is convenient, it also makes sometimes indexing kind of tricky. So for example, in this case, if you want to extract value is associated with the subnext key, but this whole thing, the dictionary is the value of this next key, and this whole dictionary is the value of this key 1. So if you want to extract value, you first have to index key 1 to get this whole section. Then you have to index next key to get this whole section, and then you have to index subnext key to get value, and then finally you get value as the output. And then dictionaries have some methods that are unique to them. The first one is the .keys method. It's self-explanatory. It returns the list of all keys. So in this case, if I have a dictionary like this, if I do the .keys method, it just returns key 1, key 2, key 3. Similarly, if I do .values, it returns all the values of the method, 1, 2, 3. And then if I do a .items, we actually get a tuple of all of the different key value pairs. So in this case, key 1, 1, key 2, key 2, key 3, key 3. We get them as tuples. So it's a list of tuples of items. You may not use some of these methods, but like we said earlier, it's good to know that they exist. And then these are some now try this exercises to get you some practice with dictionaries. And now we'll move on to comparison operators. We've pretty much finished with all data types and data structures. So now we'll just shift gears a bit and talk about something that we've referenced here and there, and that is, of course, comparison operators. So comparison operators in Python are exactly like how they are in math, and they're specifically important because they output a Boolean value. And like we mentioned when we covered Booleans, you'll be using both comparison operators and the resulting Boolean to check for conditions, evaluate when certain loops need to end, but also when you want to filter data sets later on to meet a certain criteria that you set for it. So in this case, here are just a list of all of the different comparison operators and what they do. So in this case, if you want to check if two things are equal, it looks like this. Notice that when you want to check if two things are equal, it's a double equal sign, not a single equal sign, because a single equal sign is an assignment, double equals is a comparison. So remember that. That's a very common mistake where sometimes people forget that comparison is requires a double equal sign, and it creates a very annoying error. So then if you want to do not equals, you do a exclamation point equal. So in this case, if I want to run if 4 is not greater than or equal to 5, it says it's true. But if one is not equal to 1, it says false. So same thing with greater than, less than, greater than or equal to, less than or equal to. So yeah, this is a very short section. It's basically a review of all the comparison operators in math, and just to show you that they exist in Python and they can just be used readily. And you'll mainly be using these a lot as I said earlier, in conditions, loops, and filtering. So now we're going to move on to another very, very important aspect of programming, and that's what's called functions. I've said the word function quite a few times, but never really fully explained what they are. So now we'll get into that. So a function is a chunk of code that either you or someone else has written that you know is going to be used more than once. So instead of having to rewrite the same code over and over again each time you need to use it, instead keep it in its own special structure that allows you to call it or access it in a format like the one that we've seen before, where we have the name of the function, open close parentheses, and then we can call on the function to do its task for us. And this way we have a fairly painless way to access important chunks of code that do a certain task without having to write it ourselves or rewrite it ourselves. So an example of that would be the length function. Before the length function was created, programmers had to find the length of a string or a list manually, and that was always often very tedious work. But then they realized that because this is such a common operation, it would be beneficial if we could just write it once and then store it in a function, so that any future programmer could just call the function like this, and then just get the length of a string or a tuple without having to actually write the code to do it themselves. So in that end, it facilitates code reuse, which is a very important aspect of programming. You want to make your code as reusable as possible. So let's see how functions look like. So in order to create a function, you have a def, what's called def statement, and that's def stands for define. So in this case, you're defining a function, and then you have the name of the function. You open the parentheses, and then you have a set of arguments. So now, throughout this lecture, I've kind of used the word parameter, but also argument, and I may have used them both interchangeably, but they each have a very distinct meaning. A parameter is the actual variables that you input to a function that act as modifiers. These are basically options that a function can use to alter the way it does a certain task, or to affect the way that it works on whatever object that you want it to work on. The actual type of the of these option is what's called the argument. What's called the parameter. But the argument is the actual value of the option. So just as an example, let's say that you have a function that accepts two lists, and let's just say that when you define the function, you have the name, and then you just say A, B, or list 1, list 2. In this case, the list 1, list 2 are the parameters. But when you actually call the function later on to do a certain tasks, you'll pass in two real lists as the two options, and those real lists that you'll be passing are the arguments. So the parameters are just the placeholders. The arguments are the real values that you'll be passing into functions to actually do the task, or to modify the way the function does the job. So you have the parameters. In this case, it's called arg1, arg2, but in this scenario, they're parameters, not arguments. And then you have a colon. And then, this is very important. Once you go to the next line, it's important to indent using a tab. Python is very white space heavy. It's one of the effects of having minimal syntax is that when you want to show that a certain chunk of code belongs under a certain label. So in this case, if you want to tell Python that all of this code goes underneath this function, you indent it to show that all of this comes under this line of code. So in this case, this first thing you see is what's called a doc string. A doc string is a special string that you would put in a function that you wrote yourself to actually tell readers or people who are checking your code out what your function actually does. Because it's very important to make sure that like your code is well documented. In other words, it's very heavily explained what exactly your code does and what its purpose is, and that extends to functions. So you want to make sure that for every function that you write, it's well documented what its purpose is, what kind of inputs it accepts, what it's meant to output, and what the actual structure of what the internal structure of the function is. So in this case, this doc string will just explain whatever this function does, and then you write your set of code here, and then that's it. So just to illustrate, here's a simple hello function where you do def say hello, and then there's no parameters accepted, and it just prints hello when you call it. So then so now that I defined it, once I call it say hello, it just prints hello. So this is how you define a function, and this is how you call it. So then let's do a function. Let's show an example of a function that has a parameter in it. So in this case, I'll do a simple function where it greets it greets whoever's name is passed into the function. So in this case, I have a def greeting, and then I pass in a name, and then I print out hello, and then the name of the person passed in. So in this case, if I pass in Bob as the option for the function, it prints out hello Bob. So functions can also return things. Like we already used functions that return some kind of object. For example, back when we were talking about lists, we saw how the .pop method, a function and method can be used interchangeably sometimes. But a method, the .pop method returns the actual element that you deleted from the list. So in order to make that work, for example, if I have a very simple addition function that takes two numbers and returns the sum of them, the syntax looks like this. I do return and then whatever I want to return. So in this case, I want to return the sum of num1 and num2. So then this is what it looks like. I do add num4 comma 5, and then it returns 9. And you can also, like we previously showed, that you can input the result of a return function into a variable and then print the variable like this. So now those are all very, very simple functions. Now we'll briefly go over what a real function looks like, and this is an example of how to calculate of how to determine if a number is prime or not. It's a very, very popular classic program, and I specifically want to call your attention to two concepts, three concepts that we haven't discussed before that are very important. The first one is loops. As you can see here, we have this keyword called for, and that illustrates that this is a for loop. Now, what a for loop does is that it checks to see that whatever that it repeats the set of conditions underneath it for however long as this criteria hasn't been met yet. So in this case, the full for loop statement says for n in range 2 to num. Range is a function that basically returns a list based on the range that you provide. So in this case, depending on whatever number I pass in, range returns a list that comes from 2 to whatever the number is. So let's say that I gave it is prime the number 10. Range will return a list that goes 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this for statement says for n in range of 2 to num. So in this case, for every number in this list, do the set of actions. So that means that it will repeat this exact same set of instructions for every number in the list. So it will start at 2, run all this. It will move on to 3, run all this. 4, run all this. 5, run all this. All the way up until it reaches num, or whatever number we gave it. Then it will stop. Unless this condition is met. Here we have an if statement. And an if statement is a simple, like we said before, it's a condition. It checks to see if whatever is on the right side is true, then execute these set of commands. So in this case, if the mod, remember how I mentioned how the mod will come into play and will be very useful. If the num mod n is equivalent to 0, in other words, if the division of this number and n, the n that comes over here, if the remainder is 0, in other words, if it's evenly divisible by whatever n is, then we know that it's not prime, because we know that for prime numbers, they're only divisible by themselves and 1. So if the number that we passed in is evenly divisible by any number within this range, we know that it's not prime. And if it is, we break right out of it. If we never do it, then if we go through all the numbers within this list that we created from range, and then we find that none of them get us a remainder of 0, then we know that this is prime, and thus we can easily print that this number is prime. So here we see an example of a for loop, an if statement, a break statement, and then an else statement. There's full examples of all these things in the cheat sheet, and I recommend you take a closer look at that, but also take a closer look at this function and how it works in this notebook. And as you can see, there's a improved version of this function that you can look at in your own time. And then here we have a now try this, where we'll ask you to write a very simple function that tries to capitalize certain letters in a string. So now we'll move on to something that's also very important when programming, that is dealing with errors and what are called exceptions. So we've already run into some errors throughout this lecture, like when we try to append a new value to a tuple, or when we try to access a variable that didn't exist yet. All those different things are what we're called examples of errors. They're examples of when we wrote a syntactically incorrect Python sentence, an incorrect Python sentence, where Python looked at what we wrote and decided, I don't understand what you're trying to tell me, or I don't really get what you want me to do, and then doesn't even bother trying to execute the commands that you're given it. Those are what are called errors. It's a severe problems in your code that prevent the program from running at all. But there's also another kind of mishap that is called an exception. An exception is when you write a bunch of code that is syntactically correct, where Python takes a look at it and seems to say, okay, everything's fine, and I think I know what to do. But then once it actually tries to execute the commands that you wanted to do, something goes wrong. Those are what's called exceptions. And both of those different types of mishaps will happen at one point in your programming career, and it's inevitable. And it's very important that you anticipate them happening, and most importantly, know how to handle them when they do. So the way to handle errors is to fix errors. They're very the most often just mistakes that are made in your code, and and it's very, very obvious when what an error is or where an error is, because in the case of a syntax error like this, it tells you very clearly what's wrong, and you can probably tell what the error is in this scenario, and it's that you did not end the string properly where it should. But exceptions are a bit more tricky, and sometimes you don't really know why an exception occurred. So to actually make it easier for yourself to debug your program and make sure that everything runs smoothly, you want to structure a lot of the commands that you know could potentially raise an exception or could cause an exception to occur, and put them in a certain format such that your program will automatically tell you exactly when the exception occurred, why it occurred, and what kind of exception it is, so that it's easier for you to understand how to fix the problem later on. And that structure is what's called try and except blocks. A try block is self-explanatory. It's a set of commands that you would like Python to try to execute. And once again, because these are exceptions, we are under the assumption that these are syntactically correct statements. In other words, these statements won't cause errors, they will only cause exceptions. So Python will try to execute them, but if in the process an exception occurs, there will be an except block that will try and catch this exception and will spit out a message that will tell you, the programmer, or even a user, what the exception was and potentially where it occurred. And there will be an except block for every possible exception that the code in your try block can raise. So in the case of a file read, if you're trying to read a file, and for whatever reason you want to open a file and that didn't work properly, you would want to create an except block that specifically deals with the situation where a file reading fails. And then you can just say error, that the file didn't read properly. And if there's another exception that could possibly be raised, you create its own separate except block to handle that, and so on and so forth. And to show you an example, here's that exact example that I was talking about. So in this case, I want to try opening a file called test file. And the way we open a file is with the open function. We open and then we write the name of the file. Well, more specifically, we write the path of the file. But in this case, I'm assuming the file is in the same folder as this notebook, so I just call it by the file name. But in the case where I want to open a file that's in another folder or another directory, I would write down the full path to the file, and then I do comma, and then these are the options or the permissions that I want to give to the file. So in this case, W is for write. So I want to give write access. I want to actually modify this file and actually write something to it. So the other options are read, where I only want to read from this file, I don't want to write, or read write access, where I want to read from the file and write to the file. But in this case, I only want to write to test file, and I want to write specifically. I want to write test write this to this file. Now, just from this, a potential exception that could occur is that trying to open the file goes wrong somehow, and usually, like we stated before, Python, because these are all syntactically correct statements, you as a programmer won't know that something went wrong until the very end, when you get a result that you weren't expecting and you have no idea why that happened. So in order to figure out why it went wrong, specifically where it went wrong, that's when you use stuff like except blocks to try to actually raise a message to you when something like this happens. So in this case where trying to read a file goes wrong, that's what's called an IO error. So you write a except block for an IO error, where it just states error, could not find file or read data. Otherwise, if these commands executed successfully, you just write content written successfully, and then you do f dot, and whenever you open a file, you always want to close it. So once you open it, you also want to do the complementary .close function afterwards. It's just good practice, always do it. And if I run this file, as you can see, it says content written successfully. And keep in mind, the reason, one reason for that is because with the way the .write function works, if the file doesn't already exist, it creates one and then writes to it. So in this case, the file wasn't the file didn't exist previously, but once I executed this command, it checked to see if the file existed. It didn't, so it created one and then it wrote to it, which is why it says content written successfully, and why everything went okay. But let's see if I only give it read permissions and then try to do the same thing. As you can see, we get error. We could not find file or read data. So now this is very important, because this is an exception. It's not something that Python could catch before it starts executing statement, because according to it, everything that you've written so far is fundamentally correct Python, and it's only until we try to actually do something with the file later on that you will realize, wait, something went wrong, and then maybe trying to write this file didn't work. But in order to know for sure, it's you should always try to structure your code in try except blocks to anticipate any potential exceptions or certain weird behavior, so that it's easy for you to figure out where stuff went wrong or stuff didn't go the way you thought they would. So here's another example of that. And those were try and except blocks. But now we move on to something what's called finally block. Now a finally block is pretty simple. It's a block of code that will run regardless if things went wrong or not. So let's say that there's a certain type of code that you want to execute even if there was an error or not, because previously if there was an exception to a try block, to a piece of code that you're running a try block, the program would stop running once it hits the exception, and it won't continue. But if you have a finally block, even if an exception was raised, or if it wasn't, it still executes the finally block of code that you want to enter. So an example of that would be, if I want to open test file and then write to it and close it, and then put finally and then print always execute finally code blocks. And if I run again, you'll notice the always execute finally code blocks shows up, because regardless of whether or not this works, this will always execute. And same thing, just to showcase that, I have this function that asks the user to input an integer. So I'll give you two examples, one where I do it and one where I don't. So let's see. In the first case, I won't input an integer, so I'll put a u. So as you can see here, like there was an error, but also as you can see, even though there was an error, this finally block still executed. But now let me do that again, but this time when I do type in an integer, everything went fine, and the finally block still executed. So just to illustrate, finally blocks are for pieces of code where you want it to run regardless of what happens within the try except blocks. And there's some additional examples of that. So yeah, that's everything to do about handling exceptions. And there's an now try this for this one as well. So finally, we'll continue to our last section, and that is modules and packages. So a module is essentially just another Python program that you're importing into your own so that you can reuse whatever code is in that file. Because when we talked about functions before, we mentioned how the reason why functions were created were because programmers foresaw that those particular chunks of code could be reused multiple different times in different contexts, but also by other programmers. So they put it in a standardized location and in a standardized format so that it would be easy to be reused by other programmers in the future. But sometimes it's not just one function, it's a set of functions that a programmer sees could be reused. So they put all those different functions or even objects or variables into a file and then export that file to be reused. And then when other programmers want to use some of those code that was written, they just import the entire file, and then they have access to all the different functions or objects that were listed in there. So this is very important to understand, because one of the libraries that you'll be working with later on, NumPy, is a module. It's a file that contains a list that contains a bunch of different useful objects and functions that will make your life very easy when working with datasets. So that's what a module is. So I have here an example of a module. It's called the math module, and the math module is a Python file. It contains a list of very, very useful auxiliary math operations. So in this case, in base Python, base means basic Python without any extra extensions. There isn't really a function for rounding, but in the math library there is. So with the math library, once you import it, you can call the ceil function, and the way you do it is you do math, the name of the library, dot, and the function ceil, and then you pass a number that you could use to round. So it's ceiling rounding, which means you round up. So you pass in a decimal value, a decimal number, and then you round up to the nearest whole number. So in this case, math.ceil 3.2 yields 4. So that's an example of reading a module and then using one of the functions in the module. And you'll be doing a lot of this when we talk about NumPy. So now that's what a module is. A package is, if a module is file, a package is a folder. So a package can contain multiple different modules within it, multiple different files, or it can contain other packages themselves. So it's just another layer in the hierarchy for how to structure files that could be reused and imported by other programmers. So for the most part, we'll mainly be reading modules and packages, but and we won't really be writing any. But just in case, I've listed some examples of how writing modules works, and you can take a look at that on your own time, just in case you're curious about how the process works. So yeah, there are a lot of built-in modules into base Python that are already available to us without using any import statements. But two of those are what are called the dir and the help functions. So The dir function basically gives us a list of all the different functions that are listed in a certain file. So in this case, if I wanted to find the names of all the different functions that were in the math module, I would just do dir math. And as you can see here, there's all this list of functions that are available to us in the math function. So for example, stuff like sines, logs, infinite, gamma, like factorials, exponential, stuff like that. So all those different things are functions that are available to you once you import the math module. And then the second module is what's called the help module. And the help module is exactly what it sounds like. It gives you a brief description of what the function does. So just in case you hear about a function and you want to know what it could be used for, you just type in help, and then the name of whatever function you wanna find more about, and then it'll basically print out the doc string. So remember how we talked about the doc string when discussing functions? This is exactly why you want to include doc string in functions that you write. So when other users or other programmers, if they want to immediately find out what your function does, they could just type out this little command, and it'll print out the doc string. So and it'll basically tell them what this function is meant to do and what kind of inputs it's supposed to carry and what kind of outputs it produces. So yeah, that's everything about modules and packages. And with that, that's the end of today's lecture. I know there's a lot of material, but hopefully you managed to pull through it. Once again, I heavily recommend that you go back through this notebook along with the cheat sheet in your own time, and really spend some time with it and studying what some of these concepts are in detail. Because, like I said, I skipped over a lot of material and you just went through certain things very fast. So it's very important that if you are confused or even just curious about certain things, to go back over this notebook as well as the cheat sheet in order to fully flesh out your understanding of certain concepts. And there's also a list of resources, very handy Python resources available to you for if you want external sources on how to learn Python that I've listed right here. So yeah, that's it for today. Remember to get started on those now try this exercises that are up here. And with that, I'll see you next time.